According to the National Electrical Code, the size of the conduit must be large enough to accommodate the number and size of the wires inside it. We will use the fill calculation method to determine if the control wires can be added. Firstly, the cross-sectional area of the three number 1 American wire gauge wires is calculated. Each number 1 American wire gauge wire has a cross-sectional area of 0.625 square inches. Since there are 3 of these wires, the total cross-sectional area is 3 times 0.625, which equals 1.875 square inches. Secondly, the cross-sectional area of the number 6 ground wire is 0.25 square inches. Thirdly, the cross-sectional area of the 2 number 14 control wires needs to be determined. Each number 14 control wire has a cross-sectional area of 0.03125 square inches. Since there are 2 of these wires, the total cross-sectional area is 2 times 0.03125, which equals 0.0625 square inches. Now that all the individual wire areas have been calculated, the total wire cross-sectional area can be determined by adding all these values together. This is 1.875 plus 0.25 plus 0.0625, which equals 2.1875 square inches. The conduit fill percentage is then calculated. The fill percentage equals the total wire area divided by the conduit area, then multiplied by 100%. In this scenario, a 1 1/2 inch rigid conduit is used. This conduit has an inside diameter of 1.660 inches. Using this dimension, the area of the conduit is 2.178 square inches. To calculate the fill percentage, divide the total wire area of 2.1875 square inches by the conduit area of 2.178 square inches. Then multiply this result by 100%. This gives a fill percentage of approximately 99.99%. According to the National Electrical Code, rigid conduits are limited to a 40% fill. Therefore, it is not permissible to run 2 number 14 control wires in the same 1 1/2 inch rigid conduit with 3 number 1 American wire gauge wires and a number 6 ground wire, as the fill percentage exceeds the National Electrical Code requirements.